Dye penetrant examination is an important method of non-destructive testing of materials. This is the basic principle. Often the surface of a workpiece is covered with rust or paint, which masks the material defects, as shown in the sectional view. Therefore, the first step is always the pre-cleaning of the test piece surface. This must be done very thoroughly so that any defects present, here it is a crack, are open to the surface. In the second step, the penetrant is applied to the test piece, usually red-colored low-viscosity oil. Due to the penetrant's high surface wetting capability, it penetrates into the defects and cracks. After several minutes of dwell time, the third step is to rinse the part's surface cautiously with water. The water removes the penetrant completely from the surface, but leaves it in the crack. Now, the fourth step. After drying the test piece, a developer is applied onto the surface. The developer is a fine-grained white powder suspended in a liquid. It forms an even coating on the surface. After drying, it draws penetrant from the crack out onto the surface. The location of the crack is indicated clearly on the surface. And this is how it is carried out in practice. We wish to inspect two samples, a segment of a worm gear shaft and a broken bicycle crank arm. Both test pieces have already been cleaned. First in line is the worm gear shaft. The material tester applies the penetrant. After a dwell time of about 10 minutes, she removes the excess penetrant from the surface by rinsing the test piece gently with water. She takes care not to rinse for an unnecessary long time, because the penetrant is supposed to stay in the defects. Now she dries the surface of the sample with a cloth to absorb the excess water. As the final step, she applies the developer and lets it dry. That's it. Several cracks are indicated on the surface in deep red color. Next, the broken bicycle crank arm has to undergo the dye penetration test. Spraying with penetrant, allowing to soak, rinsing, drying, and applying developer. Clearly, additional cracks are indicated on the fragments. Finally, the pros and cons at a glance. Advantages of this test method are: almost all materials can be tested, and the method is simple and low cost for a single inspection. Disadvantages are: only suitable for surface defects. No information about the depth of flaws can be gained, and rough surfaces are difficult to test.